A normal support account cannot administer a domain controller. But imagine that it can manage a forgotten group. That group controls a management server. A privileged administrator also uses that server. Those facts can form one dangerous route. That route is called an attack path, a chain of relationships that could let one compromise reach a higher impact asset. Think of it like a metro map. No single station explains the journey. The risk appears when the connections create a route from an ordinary stop to the control center. In this original CipherVibe guide, we explain Active Directory through a fictional defensive scenario. We map users, groups, computers, permissions, and administrative sessions. Then we break the route at several points. This is not an intrusion walkthrough. The environment and evidence are synthetic. We do not demonstrate credential theft, payloads, exploitation, or intrusion commands. Test only systems you own or are authorized to assess. Active Directory Domain Services stores information about identities and resources in a Windows enterprise. A forest is the broad security boundary. Inside it, one or more domains organize objects such as users, computers, groups, and service identities. Domain controllers store the directory database, authenticate users and computers, and help enforce policy. Kerberos is the preferred authentication protocol in modern Active Directory domains, while NTLM can still appear for compatibility. Authentication answers: who are you? Authorization answers: what are you allowed to do? Groups make authorization manageable. Instead of granting 100 people access individually, an administrator can grant a security group permission and manage its membership. Group policy can apply settings to computers and users. Access control entries on directory objects define who may read or change them. These features are useful because relationships scale. They are risky for exactly the same reason. Nested groups, delegated permissions, local administrator assignments, service identities, trusts, and administrative sign-ins can interact in ways no single spreadsheet reveals. Our fictional company is Northstar, using the documentation domain northstar.example. Maya has an ordinary support account. She belongs to Helpdesk, which has limited password reset duties for standard users. Months ago, a project owner delegated Helpdesk the ability to change membership of a group called App Support. That group was later granted local administrator rights on management server MGMT03. The project ended, but both relationships remained. A domain administrator occasionally signs in to MGMT03 to solve urgent problems. That creates a privileged access boundary problem. A high-value identity is using a system controlled by a lower trust group. Nothing in this story says Maya is malicious. The concern is exposure. If her ordinary account or workstation were compromised through any common entry point, the inherited permissions and administrative practices could create a route toward greater control. The safe demo screen shows only a relationship graph: Maya to Helpdesk, Helpdesk to App Support to MGMT03, and the management server to a privileged session. No attack is executed. First edge: Helpdesk can change App Support membership. That means a compromised Helpdesk identity could potentially influence who receives App Support privileges, depending on the exact access control entry. Second edge: App Support is assigned local administrator rights on MGMT03. A member therefore has high control over that server. This does not automatically grant domain administrator rights. Third edge: a domain administrator signs into that lower trust server. Microsoft guidance emphasizes separating administrative tiers because a compromised lower-tier device must not be able to influence higher-tier identities or systems. The session creates exposure that defenders must remove, even though the exact consequence depends on configuration and protection controls. Now connect the edges. An ordinary identity can influence a group. That group controls a server. That server is used for privileged administration. The path is important even if every individual setting once had a reasonable business explanation. Path analysis does not prove that an attacker succeeded. It identifies plausible control relationships that deserve validation, prioritization, and remediation. A graph is a hypothesis until defenders confirm its data. Start with the directory's effective permissions. Which principal can change App Support, and is that right direct, inherited, or delegated through another group? Next, verify effective membership. Nested groups can make access indirect. Review the policy or management system that grants local administrator rights on MGMT03. Then inspect approved identity and endpoint logs for privileged sign-ins to that server. Use read-only assessment wherever possible, work from an authorized inventory, and preserve timestamps and scope. Directory graph and exposure management tools can help correlate relationships at scale, but their collection methods, freshness, coverage, and licensing differ. Validate high-impact findings against the directory, policy source, and endpoint evidence before changing production access. For our practical example, the evidence confirms all three edges. The finding is not domain compromised. The accurate finding is a lower trust support identity can influence administrative membership on a server used by a control plane administrator, creating an avoidable privileged path. Northstar removes helpdesk stale ability to manage app support and gives membership approval to a narrowly scoped owner. It removes app support's unnecessary local administrator assignment and replaces broad standing access with a time-limited, audited workflow where the platform supports it. Most importantly, domain administrators stop signing in to ordinary management servers. Privileged work is performed with separate administrative identities from hardened, trusted administrative devices. High-privilege accounts are not used for email, web browsing, or routine support. The team also rotates credentials or secrets that may have been exposed, reviews recent membership and sign-in activity, and monitors future changes to sensitive groups, delegation, policy, and privileged logons. One fix can break the illustrated route, but defense in depth matters. Removing stale delegation prevents the first jump. Reducing local admin limits server control. Administrative separation protects the control plane if a lower tier fails. Monitoring helps detect the next unexpected connection. A traditional access review asks who belongs to each privileged group. That is necessary, but it may miss a user who can modify the group without currently belonging to it. Configuration assessment checks policies, delegation, service identities, domain controllers, and administrative hosts. Graph analysis connects those facts and helps prioritize routes to high-impact assets. Monitoring shows when membership, permissions, policies, or privileged sign-ins change and whether a risky relationship is being used. Use inventory and baseline assessment when establishing hygiene. Use path analysis when many indirect relationships make manual review difficult. Use continuous monitoring because a clean assessment becomes stale as administrators, applications, and projects change. Do not treat a graph score as proof of compromise, and do not remediate by deleting groups blindly. A relationship may support a production service. Confirm ownership, dependency, and rollback before changing it. The objective is to preserve legitimate administration while removing unnecessary control paths. Common mistakes include focusing only on direct domain admin membership, allowing privileged identities to sign in to lower trust systems, leaving project groups and delegated access after the work ends, granting broad local administrator rights, and ignoring service identities or management platforms that can influence the directory. Another mistake is collecting sensitive directory data without a clear authorization and protection plan. Relationship datasets reveal valuable details about an organization. Restrict access, encrypt storage, set retention, and do not upload production directory data to unapproved services. Finally, do not confuse Active Directory with Microsoft Entra ID. They can be connected in a hybrid environment, but they are different identity systems with different objects, protocols, roles, and controls. Hybrid dependencies can extend the control plane, so scope them deliberately. Specific event identifiers, audit settings, and available protective features depend on Windows versions and organizational configuration. Fact-check those implementation details against current Microsoft documentation before deployment. Active Directory is a system of identities, resources, permissions, policies, and trust relationships. An attack path is a plausible chain through those relationships, not proof that an attack happened. Remember the metro map analogy. A low-risk station can become important when several connections lead to the control center. Defenders reduce risk by removing stale delegation, minimizing standing privilege, separating administrative identities and devices, protecting domain controllers and the wider control plane, and monitoring changes. Your practical action is to choose one high-impact group or administrative system in an authorized environment. Work backward. Who can change its membership? Which groups are nested? Which devices can administer it? Where do privileged identities sign in? Record the evidence and break one unnecessary connection through an approved change process. The goal is not to memorize attacker commands. It is to understand how legitimate control relationships combine, then design the directory so one ordinary compromise cannot become an enterprise-wide event. This is original CipherVibe educational content for defensive, authorized use only.